Quantum number part 9, that is magnetic quantum number, which is also called as orbital orientation quantum number. Represented by small m. We have seen that s orbitals are of one type, p orbitals are of three types, d orbitals are of five types, f orbitals are of seven types, and g orbitals are of nine types. F orbitals are seven types, and g orbitals are of nine types, and so on. Thus, for a given value of azimuthal quantum number, total number of m values is equal to 2l plus 1. In this way, m value depends on l values. Now, representation of s, p, and d orbitals. If the value of l is 0, then the value of m is only of one type, that is 0. So s orbital is of only of one type. S orbital is of only one type. If L is equal to 1, then there are five values of M, five values of magnetic quantum number. M is equal to 0, plus 1, and minus 1. If the value of M is 0, then the p orbital is called as px orbital. If the value of M is plus 1, then p orbital is called as py orbital. Similarly, if the value of m is minus 1, then the p orbital is known as pz orbital. If L is equal to 2, then the values of M are of 5 types. That is 0, plus 1, minus 1, plus 2, and minus 2. If the value of L is 2, then D orbital, that is D orbitals are of 5 types, and if the value of M is 0, then D orbital is known as dz square orbital. If the value of M is plus 1, then the D orbital is called as dxz. If the value of M is minus 1, then the D orbital is known as dyz orbital. If the value of M is plus 2, then D orbital is called as dx square minus y square. And if the value of M is minus 2, then D orbital is known as dxy orbital. F and G orbitals are very complicated. So this is all about the magnetic quantum number. Now there are a few questions. Question number 1. Write correct orbital notation for each of the following set of quantum numbers. First, n is equal to 1, L is equal to 0, and M is equal to 0. Second, n is equal to 2, L is equal to 1, M is equal to 1. Third set, n is equal to 3, L is equal to 2, and M is equal to minus 1. Now answer. If n is equal to 1, and L is equal to 0, M is equal to 0, then the orbital is 1s. If n is equal to 2, that is d orbital, that is p. If n is equal to 2 and L is equal to 1, L is equal to 1 means p orbital, that is 2p orbital, and M is equal to 1 or M is equal to plus 1. So the orbital notation for this set will be 2py. If n is equal to 3, principal quantum number 3, L is equal to 2 that is d orbital. Now m is equal to minus 1, that is dyz orbital. Next question. What are principal quantum number, azimuthal quantum number, and magnetic quantum number values for 2s orbital, for px orbital, and 3d xy orbitals. For 2s orbital, n is equal to 2, l is equal to 0, and m is equal to 0. For 4px orbital, n is equal to 4, l is equal to 1, and m is equal to 0. For 3d xy orbital, n is equal to 3, l is equal to 2, and m is equal to minus 2. So this is all about for today. Thank you.